Imagine a massive gathering attended by a constant number of planets, stars, and moons, all playing together superbly. Regardless, there is one particular component of this ensemble that has shocked experts in space for an extremely important time frame: exoplanets. Exoplanets are ordinary planets that are not part of our system, hidden away somewhere deep in the Milky Way. It might surprise you to learn that among the enormous number of exoplanets are objects in the galactic system, so similar to Earth, so temptingly similar, that they may be our divine twin of the planet. We dive into the fascinating space of Proxima B, found just 4.2 light-years away. The James Webb Space Telescope is causing trouble for our journey toward understanding these divine secrets. Imagine for a moment that your mind travels across the vast magnitude of our world, the Milky Way, where more than a quadrillion exoplanets live. That's a 15-digit number with zeros. To put this number in perspective, if each of these exoplanets were the size of a sand grain, we would not simply fill the Grand Canyon. We'd have enough to create a new landmark on Earth, a 2.0-mile wide Grand Canyon that would stretch a great distance. It is generally surprising that around 20% of these magnificent bodies are deemed Earth-like in terms of geology and air structure. That means there is a 1 in 5 chance of seeing a twin of our world. And the story doesn't end there. These planets are close by, and there could be an additional 4 billion moons. Rough satellites like our moon that are trapped in a gravitational dance with their parent stars. If you somehow manage to think about finding a different body in space that can or might contain life, the universe offers a flood of chances now that the material has been distributed on an unimaginable scale. It's time to introduce the expert. Worker prepared to paint its complex nuances. The James Webb Space Telescope. This heavenly Sherlock Holmes. With its displaced amplified central focal point through adaptable central beats, surpasses even the most sophisticated optical instruments. We are not talking about any focal point. Primarily, it's 6.5 meters long, with mirrors that are 2.7 times larger than Hubble's. Try to imagine as much detail as you can, distinct even in the tiniest blaze of a star billions of light years away. And then analyze the nuances of orbiting planets. What distinguishes the James Webb Telescope as revolutionary isn't simply its seeing power, but also its highly advanced technology such as cutting-edge sensors and spectrometers. These instruments can do considerably more than simply observe. They are able to evaluate and direct the extraordinary light marks released or reflected by great objects, which can be deciphered to reveal their atmosphere, harmony, thickness, and even mass. Acting as space scientists, they can figure out whether or not a planet has water, compounds, or oxygen included. The James Webb Space Telescope has the ability to respond to these inquiries, transforming from a straightforward observer to a scientific genius. It's not just an advance over Hubble, its predecessor. It's more or less a quantum change. If Hubble's discoveries shocked you, prepare for a real celebration of radiant discoveries. Just as we extended our look across the universe's intricate landscape, it's worth zeroing in on one specific star, Proxima B, since its discovery in 2016. This baffling planet has stood out as a legend from Shakespeare. Full of problems and unpredictability, awe-inspiring astronomers and anthropologists alike. What's the matter, despite the conflict? To begin with, Proxima B is basically in our galactic area, located 4.2 light-years from Earth. To put it into perspective, if you could travel at the speed of light, you'd arrive in just shy of 4 years, or roughly the same time it takes for your favorite program to enter reruns. But let's dive deeper into why this planet is so critical. We're examining a universe that spans more than 93 billion light-years from one end to another. So, discovering a planet that is so close and so encouraging for scientific research is like finding a precious gem among a pile the size of Mount Everest. A treasure with potential that holds enigmas regarding existence itself. In the grand universe's tapestry, Proxima B is a complicated thread that provides us important clues that could change how we comprehend habitability and life beyond. Earth. It's not just Proxima B's nearness to Earth that excites established experts, but also the compelling evidence that this planet is not just Earth-like, but potentially Earth 2.0. What is Proxima B's comfortable position? Space specialists call it the habitable zone surrounding the parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine meandering waterfalls, oceans perhaps, and vast lakes and streams as deep and mysterious as the Mariana Trench. But before we begin dreaming about visiting Proxima B, we ought to take a look at a few of its peculiarities. One day on this captivating exoplanet lasts for an incredible 11 days. Sunrises not only introduce a new day, but unfurl slowly, resisting giving way to afternoon, and sunsets linger, creating bright hours that photographers long for. While it appears idyllic, it also has significant effects on the climate and adaptability. How would human biorhythms adapt to the patterns of dark and light on Proxima B? Would we really need to eat 3 or 4 times as much on that planet in a single day? Would we sleep similarly on this bizarre world? The fundamental patterns of life, as far as we know, would be simultaneously intriguingly comparable and frustratingly peculiar. It's as though nature is giving us a riddle wrapped in a mystery, testing our understanding of what makes a planet livable. You might wonder how we can gather accurate information about a world we've never visited. The James Webb Space Telescope delivers all its capabilities like a giant Swiss Army knife. It goes beyond merely a telescope. It's a sophisticated research lab in the vacuum of space. It's because of its cutting-edge technology. Cosmologists do more than just look at planets. They examine them through the lens of scientific instruments that would make CSI labs appear basic. Using advanced spectrographs, the Webb telescope can examine the reflected and emitted light by these distant planets. Each element or compound in a planet's atmosphere absorbs or releases light at a particular frequency. By concentrating on these patterns, scientists can perform a remote biopsy of celestial bodies, determining not only atmospheric pressure and density, but also the possible presence of essential organic compounds like water, carbon molecules, and even oxygen. Space science is not just cosmology, space detective work. We don't sit idly waiting for clues to come to us. We actively seek them, exploring the atoms and molecules that constitute these complex worlds. The Webb telescope is more than just an eye in the sky. It's a highly specialized research lab, investigator, and detective all in one. We are able to turn our theories and hypotheses regarding alien worlds into methods for confirming or denying them, changing our understanding of what might exist beyond our blue dot. Just when you thought you had uncovered the most stunning layers of this galactic onion, the narrative takes a surprising turn. Like in any science fiction thriller, scientists using the James Webb Space Telescope detected something surprising from Proxima B, a signal so astounding that it spread throughout social media and academic halls. Named a potential technosignature. It was a complex electromagnetic discharge, so intricately designed that it could indicate the presence of an advanced civilization. The collective heartbeat of humanity appeared to reach its zenith with a discovery that looked like it would change our perception of reality. Could this signal be the concrete evidence that we are not alone in the cosmos? And yet, as suddenly as it appeared, the signal disappeared, leaving behind not just a stunning silence, but a maze of unanswered questions and rising hypotheses. Was it simply a transient cosmic anomaly, a random event of endless configuration, or something in coded message, or even a sign of extraterrestrial intelligence? The solitary mission cast a sad remnant of mystery over Proxima B, sparking wild discussion and speculation. Was it merely a passing anomaly, or does it belong to a much bigger, more perplexing story than we can imagine? But wait, the tale of our exploration of the cosmos is far from over. The ink is still wet. and new discoveries await. The chapters are still being written. This time, it's not just conventional experts, but Harvard scientists who are leading a shift in perspective. As we carry on our search for extraterrestrial life, they are not content with merely studying the signals and the anomalies we've talked about so far. By changing the perspective, they're raising the bar. The James Webb Space Telescope, transformed into a kind of enormous night vision telescope, is planned to look for sources of artificial light in both the dark and illuminated areas of distant worlds. We're looking at staggering possibilities, such as the possibility of recognizing artificial versions of dark cities that glow like excellent. SPS considers seeing the glowing light emissions. It might be a city humming with the presence of an advanced civilization. It's transmitting its glow into the vast oceans. As we continue to piece together the search for the universe's secrets, life on other planets takes on new aspects beyond the UH. With new aspects beyond the immediate interest in Proxima B, our great quest goes deeper into the vast new regions of space. This pursuit is motivated by technological advancements and a significant desire to comprehend where we fit in the universe. Advances in cosmology and space investigation have led to the discovery of various exoplanets with potential habitability. Instruments like the James Webb Space Telescope and ground-based observational facilities have grown our capacity to identify and investigate these distant planets. One particularly fascinating area of study is the search for biosignatures, signs of life. These signs could include atmospheric gases like methane or carbon dioxide, which, under the right circumstances, could suggest biological processes. The JWST's capabilities extend beyond basic discovery. Its advanced instruments can measure the atmospheric composition of exoplanets, helping scientists pinpoint potentially habitable worlds. The data collected by the telescope could reveal the complex dynamics and processes of faraway exoplanets, unveiling new information about their surroundings. With our exploration efforts continuously advancing, Proxima B remains a key subject of inquiry, guiding us into the future of space exploration and the discovery of extraterrestrial life. As the James Webb Space Telescope expands our comprehension of distant planets, the pursuit of life beyond Earth has become a major focus of research in science. The technology and methods we're using to investigate these exoplanets, like measuring the composition of their atmosphere, can offer the most straightforward evidence to date of whether they could support life. This quest isn't just about searching for familiar environments that resemble Earth, but also taking into account the vast array of conditions that may allow life to emerge in unforeseen ways. The concept of discovering extraterrestrial life, or even the simplest signs of life, carries significant implications for humanity. It challenges our view of ourselves as unique in the universe, deepening our comprehension of life's possibilities. Imagine discovering that life has evolved elsewhere in conditions vastly different from Earth's. Could life on other planets have developed tolerances for extreme temperatures, toxic atmospheres, or a lack of water? Could it thrive in environments we consider hostile? These inquiries test the limits of biology, philosophy, and cosmology. Proxima B, with the possibility of being habitable, serves as a beacon in this search. Though its conditions may differ from Earth's, it is an excellent candidate for study. Even if life doesn't exist on Proxima B, the very possibility of exploring its habitability opens doors to other star systems that could harbor life. As we continue to collect information from a distant exoplanet, we are also learning about the broader universe, refining our tools and techniques to detect life across the cosmos. One of the most exciting prospects is the possibility of finding technology-based biosignatures, indicators that life might be present or that an advanced civilization could exist. While scientists are still cautious about drawing conclusions from abnormal signals, the endeavor to find artificial light or other technological signs could revolutionize the way we think about intelligence from other planets. The idea that we could detect cities or infrastructure on distant planets opens up new avenues of inquiry. blending astronomy and the pursuit of civilizations beyond our own. This exploration is dynamic and ever-changing. It's driven by multidisciplinary cooperation. Across fields, astronomy, biology, engineering, and artificial intelligence. As technology continues to improve, our ability to navigate the universe with increased precision will only lead to more discoveries. New missions are already being planned to benefit from the Webb telescope's capabilities for future projects, aimed at investigating even more distant exoplanets and star systems. What does all of this mean for the future of space exploration? As we expand our reach into the universe, it presents us with an intriguing possibility: the investigation of a cosmic ecosystem, interconnected and teeming with potential for life. Each new discovery, whether it's the atmosphere of a planet far away or a peculiar signal from a star system, brings us one step closer to comprehending our position in the vast cosmos. But with every answer, new questions arise, questions that challenge our fundamental assumptions regarding life, the universe, and everything in between. The search for life beyond Earth is not just about finding something familiar. It's about embracing the unknown, testing the limits of our imagination, and recognizing that we are part of a much larger, mysterious universe. The future of space exploration is unfolding before us, and it is brimming with opportunities to rethink everything we know about life, existence, and the cosmos. As we move forward, the discovery of another Earth or signals from a planetary civilization may not be just the end of one chapter.